All right, so welcome back, mathematicians. We are on Unit 2, Lesson 8, comparing relationships with equations, and our learning goal for today is let's develop methods for deciding if a relationship is proportional. So we're still talking about proportions. We're going to start out with a notice and wonder, so patterns with rectangles. So the question is, do you see a pattern? What predictions can you make about future rectangles in the set if your pattern continues? So I want you to stop it and see if you can see a pattern. All right, so the pattern that I saw is, I saw that in this one we had 3 going this way and 1 up and down. This one we have 6 going this way, so we added 3. And then we added another row. So in case 1, if we call this case 1, we had 1 row and 3. This one we had 2 rows of 6. And this one we have 3 rows of 9. So that's the pattern I saw. Hopefully you saw a different one. All right, so the other day we worked with converting meters and centimeters and millimeters. And today we're going to work with Fahrenheit and Celsius. So we're going to use the equation F equals 9/5 C plus 32, where F represents degrees in Fahrenheit and C represents degrees Celsius. And we're going to complete the table. So let's see what we got going here. I seem to have lost. There it is. Okay. So we're going to turn this over, and I'm going to write the equation up here because I have short-term memory. So 5/9 C plus 32. All right, so this is telling us that this column is the C. So wherever I see C, I'm going to replace it with 20. So in this case, it would be F equals 5/9 times 20 plus 32. So when I take out my handy-dandy calculator, I would get 43 1/9. Then I'm going to replace C with 4, so that would be 5/9 times 4 plus 32. When I take out my calculator, I got 34 2/9. And then if it's 175 degrees Celsius, that means it would be, so I'm going to take 5/9 times 175 plus 32. And that's going to give me 129 2/9. All right. So we filled in the table. So now let's move on to the next part. Use the equation C equals 2 54/100 n, where C represents the length in centimeters and n represents the length in inches to complete the table. All right, so we have this equation this time. So C is going to equal 2 54/100 n. And what did n? N is inches. So this is our n column right here. So wherever I see n, I'm going to replace it with 10. So that would be 2.54 times 10. Well, that's an easy one. 25.4. Just move that decimal point over. All right, this one we're going to do 2 54/100 times 8. I'll take out my calculator. And I get 20 32/100. Then we have 3.5 inches. We want to know how many centimeters that is. So we're going to take 2 54/100 and multiply it by 3.5. And that's going to give me 8 89/100. All right. Now it says, are these proportional tables? Explain why or why not. Well, how do we figure out if a table is proportional? We do that y over x right here. So let's do our y over x and see what we get. So I'm going to take out my calculator and I'm going to do 43 1/9 divided by 20. And if I round it, that gives me about 2.2. Then I'm going to take 34 and 2/9 and divide it by 4, and that gives me approximately 8.6. Do I need to go on? No, this one is not proportional. All right, let's look at this one. We're going to do our y over x. Remember, this is x and this is y. So we have 25.4 divided by 10. Well, that's 2 and 54/100ths. We have 20 and 32/100ths divided by 8. Got that 2 and 54/100ths again. And 8 and 89/100ths divided by 3.5. And we get that again. So we have a COP here. So that means that yes, this is proportional. Okay, we can tell because it has a COP. How else could we tell? Well, let's look at the equations. So for this one, this is the equation. Is it in the form of y equals kx? Well, right here it is, but this plus 32 makes it not proportional. All right, let's look at this equation. So in this equation, are we in the form of y equals kx? We sure are. So that is another way that we could tell whether they were proportional or not. All right, so on to 8.3. Total edge length, surface area, and volume. So here are some cubes with different side lengths. Complete each table and be prepared to explain your reasoning. So how long is the total edge length of each cube? So it's something we probably need to figure out is how many edges are there on a cube. So each cube has how many edges? 12 edges, and they are all the same length. Okay, so if one of them has 3, I'm going to multiply 3 times 12 to get 36. If one of them has 5, I'm going to multiply 5 times 12 because there are 12 edges, so that would be 60. If one of them has 9.5, I'm going to multiply 9.5 by 12, which is going to give me 114. And if we have an unknown s, what did we do with all these? We multiplied them by 12 to get from here to here. So what do you think we're going to do with this? We're going to multiply it by 12, and then the correct way to write it is 12s. All right, now we're going to do the surface area. Remember, surface area is the outside, like if you were covering it with paint. So we need to know something about a cube. Well, a cube has how many faces? Each cube has, and this is a face, so how many faces does it have? 6 faces. Now, how do we find the area of a face? Well, it's a square, so we multiply side by side. So the area of this one face is 9, and if we have 6 of those, 9 times 6 is 54. Okay, the area of this face is 25. 25 times 6 is 150. The area of this face is 90 1/4, or 90 25/100ths. Multiply that by 6, and we get 541.5. Okay, and if we had s, well, what did we do to these? Well, first we multiplied the side lengths by themselves, so that was s squared, s times s, to find this area. Remember, we found this area, 3 times 3 to get 9, 5 times 5 to get 25. So we're going to do s times s, which is s squared, and then we multiplied it by the 6 because there were 6 faces on a cube. All right, now we're being asked to find the volume. Remember, volume is the area inside, so we are going to do side times side times side. We're going to take the base, the area of the base, which would be side times side, and then we're going to multiply it by the height, which in the cube is all the same number. So this would be 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. This is going to be 5 times 5, which is 25, times 5 is 125. This one's going to be 9.5 times 9.5 times 9.5. And believe me, I did that on my calculator. I got 57.375. So what did we do? We took, if this is S instead of 9.5, we did S times S times S. And that would be, if I write it out like this, the shortcut would be S to the third power. All right, question 4. Which of these relationships is proportional? Well, we can do that y over x. Remember that y over x? So let's do that. So what, 36 divided by 3 is 12. 60 divided by 5 is 12. 114 divided by 12, or 114 divided by 9.5 is 12. We got a COP here. So which of these relationships? Well, so far this one is. Let's try this one. Let's do our y over x again. So 54 divided by 3 is 18. 150 divided by 5 is 30. Well, this one is not proportional. We don't have a COP. All right, I'm going to add it over here. Kind of squeeze it in here. 27 divided by 3 is 9. 125 divided by 5 is 25. So this one is not proportional. So which one was proportional? The relationship between the side length and the total edge length. And how do we know? Explain how you know. Well, we had a COP of 12. Let's look at the equations real quick. So this one would be y equals, what does y equal? 12s. Is that in the form of y equals kx? Yes, that's in the form of y equals kx. So that is a proportional equation. This one is y equals, and we have it right here, y equals 6s squared. Is that in the form of y equals kx? No, because we have this squared right here. All right, this one is y equals s to the third. Nope, that's not in the form of y equals kx. So that's another reason the equation is in the y equals kx form. All right, now it says write equations for the total edge length E, total surface area A, and total volume with side length S. Oh, we just did that. So this would be E, because they wanted us to use E instead. So E equals 12s. This one is A equals 6s squared. And volume equals s to the third. All right. Kind of got a little ahead of ourselves there. So do you see why this is the only equation that works right here? And this is an S, not a 5. All right. So now we're going to talk about, we're going to skip the, are you ready for more? We're going to talk about all kinds of equations. So here are 6 different equations. First, I want you to predict which of these equations represent a proportional relationship. So look at them real quick and maybe circle the ones that you think would be proportional. All right, so complete each table using the equation that represents the relationship. So then they gave us these nice tables to use. So we're going to use them. All right, so the first equation is y equals 4 plus x. So they're giving us the x values, so that means we're going to substitute 2 in for x. So that means we're thinking 4 plus 2, that would give us 6. And if I do y over x, that's 6 over 2, which gives me 3. All right, if I add 4 plus 3, I get 7. 7 over 3, I'm just going to leave it as 7/3. Okay, here we have 4 plus 4 is 8. 8 over 4 gives me 2. And 4 plus 5 gives me 9. And 9 over 5. All right, how do we feel about that? All right, let's move on to the next table. So now we have y equals 4x. So that means every time we see x, we're going to put what they tell us x is. So 4 times 2 is 8. 8 over 2 is 4. Whoops. 8 over 2 is 4. There we go. All right, now we're going to do 4 times 3. That gives me 12. 12 over 3 gives me 4. Now we're doing 4 times 4. That gives me 16. 16 over 4 gives me 4. And 4 times 5 is 20. And 20 over 5 gives me 4. Oh, interesting. All right, so this one, we're going to do 4 divided by x. So that is 4 divided by 2 is 2. And 2 over 2 gives me 1. Now we're going to do 4 divided by 3. And I'm just going to leave that as 4/3. It's fine. And then 4/3 divided by 3 is going to give me, let's see, 4/3 divided by 3. So that's times 1/3. That's going to give me 4/9. Even I got to write it out to the side. Okay, this one is easy. 4 divided by 4 gives me 1, and y over x gives me 1/4. This is 4 divided by 5. We're just going to leave it as 4/5. Then 4/5 divided by 5 is the same thing as multiplied by 1/5. So that's going to give me 4/25. Let's see what we notice there. All right, now we're going to do x divided by 4. So x is 2 divided by 4 is 1/2. Then 1/2 divided by 2 is 1/4. Now we're going to do 3 over 4. Well, we're just going to leave that 3/4. 3/4 divided by 3 is the same thing as 3/4 times 1/3. That's going to leave me with 1/4. Let's see, 4 divided by 4 is going to give me 1. My y over x is going to be 1/4. And this is going to give me 5 over 4. And 5/4 divided by 5 is the same thing as 5/4 times 1/5. Oh, that's going to give me 1/4. What do you notice there? All right, now we're taking 4 and we're raising it to the power of x. So that means we're going to do 4 squared, which is 16. 16 divided by 2 is 8. Now we're going to do 4 to the 3rd. That means 4 times 4 times 4. That gives me 81. I'm starting to cheat now and use my calculator. Well, not 81. Looked at the wrong column. 64. Okay, and then 64 divided by 3 gives me 21 and 1/3. Now we're doing 4 to the 4th, and on your calculators to change it to a power, use the little button that looks like a house top, or if you do music, it looks like an accent, like that right there, okay? So you'll put in your calculator 4, house top, 4, And when you do that, you get 256. And then 256 divided by 4 is 64. And then 5, so you're going to put 4 accent or housetop to the 5th power, and that's going to give you 1024. And if we divide that by 5 to do y over x, we get a 204.8. All right, do we see a pattern there? I don't think so. All right, now we're doing x raised to the 4th power. So we're going to take 2 and raise it to the 4th power. So that would be 2 housetop 4, and that's going to give us 16. 16 divided by 2 is 8. Then we're going to take 3 and raise it to the 4th power. So 3 housetop 4 is going to give me 81. And 81 divided by 3 is 27. Then we're going to take 4 and raise it to the 4th. Oh, we already did that one. That's 256, and that gave us 64. And then the last one is 4 raised to the 5th power. Whoops, I did that backwards. 5, because x is 5 raised to the 4th power. That's going to give me 625. And 625 divided by 5 is 125. Do these results change your answer to the first question? Well, I'm betting that most of you said that one was proportional. But is there another one that's proportional? This one right here. So why do you think that one is proportional? It doesn't look like it's in the form of y equals kx. So let's look at this. So this is y equals x over 4. Can I put that invisible 1 right there? And can I rewrite that as y equals 1/4 times x? Does that mean the same thing? Yes, it does. Okay? So you answered this question. So we now know that this one is proportional and this one is proportional because their equations are in the form of y equals kx. All right. So summary, if two quantities are in a proportional relationship, then their quotient is always the same. That's your y over x. The table represents different values of a and b, two quantities that are in a proportional relationship. So we come over here and we look. Here's our y over x column, and notice they are all 5. So to write this equation, we could say that b over a equals 5. Now, it works for anything, but a cannot be 0 because we can't divide by 0. Now, can we write this in the form of y equals kx? We sure can. Y is going to be b. B equals, if I multiply both sides by a, look what I get. The a's cancel here. That leaves me with b equals 5a. Isn't that in the form of y equals kx? All right, so if it has, as long as we can represent this relationship with the equation y over x equals k, as long as x is not 0, or, and we've always talked about it in the form of y equals kx. If the equation cannot be written in this form, then it does not represent a proportional relationship. So that is super important. If you can't write the equation in the y equals kx form, then it is not proportional. All right, I'll see you on Zoom to do the practice problems.